Hi, everyone, and welcome to another episode of one of our webinars with Be My App. I'm Fernando, and once again, it's a pleasure having you all here. We're accompanied by Anthony Charbonnier from Sigfox, who will be introducing us to the LPWAN and IoT. And with that, I just want to let you guys know again, if you guys are new to here and you guys want to have more information about our future webinars and our type of hackathons and webinars and events, you can just check it out at our community.bmap.com. There you can register so that you know about our next webinar, our next hackathon. And with that, I want to present you guys to, as I mentioned, Anthony Charbonnier. He's from Sigfox, and he has to show us about wireless communication. So, Anthony, it's all yours.
Yeah. So thanks everybody. So I'm gonna show my screen right now. You're gonna see my amazing laptop. Yep. So that's better. So can you see me well? Can you see everything well?
Correct.
Okay. So hi everybody. So I'm Anthony from Sigfox. As Fernando said, my job at Sigfox is to handle all the startup relations. So from the program with startups, so basically we help them to go to prototype, to go to market, from incubators, partnership, because we partners with the best incubator in IoT in Europe to actually help them to build Sigfox products, to basically, ending also a startup program online where we, welcome startup and we give them a lot of information to build Sigfox, etc. So that's my job at Sigfox, and one of them is actually also to do this kind of talks. So this is the very first for me. Usually I'm actually used to have somebody in front of me, so this is a first one. So nobody will actually laugh at my crappy jokes in front of me. That's actually better. So we'll start by the basics of Sigfox, because people hear about Sigfox a lot, but we realize that actually nobody knows what it is in real life. So what is Sigfox? We actually created a market called the LPWAN market, and what it means is that it's a low power, wide area network market, and it's basically ultra low power and ultra long range. It's written in its name, and that's what we do. We do our own network, we deploy it with partners, etc. But we actually do our own dedicated IoT network. And we are a network provider. That's really important to understand. As I said, we are a network provider. We don't sell chips. We don't build solutions. We don't do that. We invented a radio protocol, and we use to deploy our own network. Something important to understand as well is that we deploy a global network. So it means that everywhere in the world where you have Sigfox coverage, your device are going to work the same, and you're going to get the same coverage. And it's important to know, because then, for example, roaming doesn't exist anymore. The Sigfox network has to be global. So if I want you to remember 4 things tonight, it will be these 4. First, that Sigfox is global reach. As I said again, it's one network. It will work quite the same everywhere. We'll talk about the differences in the end with frequencies, etc. But regarding the network and how it works, that's the same everywhere. It was built for energy efficiency, and this is really important, because if you want to empower real IoT as it needs to go, you need to have devices which can be autonomous up for years. Like, we have devices on our network which can go up to 10 years of battery life completely autonomously. And in order to do that, we needed to invent something completely new, because we couldn't rely on existing technology like Bluetooth or GSM or whatever. It consumes way too much. And this is why we had to invent our own technology to make it happen. So third really important point with Sigfox is that it's really cost effective. And there is different reasons for that. The first one is that as it's really, really long range, we don't need a lot of base stations to cover a country. So for example, France, we only have 1,500 base stations to cover the whole country. And it can actually appear to be a lot, but when you think about it, it's actually really few. And that's why it actually costs not so much money to cover a country. The second part of cost is actually hardware, because doing Sigfox hardware is actually cheap. We are using transceivers which are on the market 6 years, and we are making them compatible with the Sigfox network. But you don't need a Sigfox chip. You need a chip which is compatible with us, but there are existing chips on the market which actually do that. And we'll talk about that later. And the fourth point, which is really important for Sigfox, is simplicity. Because with Sigfox, it's an out-of-the-box experience. There is no peering, there is no Bluetooth setup, there is no Wi-Fi setup, there is nothing. You just put the battery in, you make it, and it just works. So this is the magic part of it. And when we do our workshop with the Arduino board, etc., this is the magic trick. And this is really, really important to know. So of course, as I said, if you want to have billions of devices, you needed to, create a new technology for it. And as we did, it will create new use case that was not invented before. Here are some of them, and you can read as much as I can. So we're talking about fire starting, sensors. We are talking about, predictive maintenance with the washing machine, for example, where the washing machine will know when it's behaving badly and will transmit some data to actually warn your maker, say, hey, I'm actually going bad, please change this piece. So that's very important. Well-connected trashes, for example, which seems completely stupid, but when you think about it, knowing if the trash is full or not will help you to optimize all your travels, to pick them up, and will actually optimize to actually know if you need to go there or not. So it's very, very important. One use case, which is also key with Sigfox, is asset management and GPS use case. It's because with Sigfox, you can have GPS trackers, which can go up to years in battery life. You put a tracker on a really expensive asset that you have. It can be a vehicle, it can be like a pallet, it can be whatever. You always know where it is, and it provides a lot of value to an enormous amount of people. So how to communicate with Sigfox? It's actually very simple, and it's that simple. The first is the most important, is to detect something interesting to send, and this is the hardest part. What sensor do you want to use? What GPS position do you want to know? So basically, what do you want to send with the Sigfox network? This is where you put your value. The second part is to power on the communication module. So it can be transceiver, a module, it can be a system on chip, whatever hardware is compatible with Sigfox network. The third is that you send it with this module. The next step is that it's picked up by our antennas, which are in the countries. And the last step is that when it's picked by these antennas, we actually will give it back to your own server. We'll push it to you. One important part to note here is that it's not our data. When you send data with the Sigfox network, it's yours. We never know what's going on in your payload, and we don't want to know. It's your data, you're the owner, and we don't use it. We never do. So how hard it is? To be completely honest, that's that simple. You just send an AT command, so an attention frame. It's normally it's one line of code. In my example I'll do later, it's going to be a couple, but it's very, very simple. And once it's done, you have to go on our server, on our backend, to set up a callback, an HTTP request, which will talk to your own server to actually get this data back, because this is nice to actually do some data with your device, but you want to be able to pick them up to use them. So that's what you do with the HTTP request on our own server. So the core concept behind it, very, very important. Here are some figures. So as I said, it was really designed for energy efficiency, and this is the most important part of Sigfox. If you want to understand Sigfox, you have to understand the concept of a device which is 99% of the time completely asleep. So Sigfox is actually done for devices which are only waking up 10 seconds every 10 minutes to send a message, and then it goes back to sleep. And this is how you can save battery and make a device go to 10 years of battery life. If your device is always listening for a message or something, it will not go up that last, and then the value is done. So this is what we did. And here's the figures of how much it consumes when it's actually sending data. So it's 20 to 35 milliamperes during the transmission, so it's a couple of seconds. And it's 25 milliwatts and 14 dB for the radio guys amongst us. And as I said, the key is idle consumption, because as I said, your device is going to be asleep for most of the time. So this is where you need to gain battery life. The key concept with Sigfox is out of the box. As I said, it's very, very easy. It has to be easy for the user. So there is no configuration, no peering, no signalization, nothing. So the device just works out of the box. Here, the network is here to serve the device. So basically, your device has to send data. The data is going to be picked by our antennas, and then we'll handle that. But your device only has to send data and it doesn't have to do something else. You just need to send data, which is very important for consuming really, really low power. One thing important is that it's actually picked up by several base stations. So we don't communicate with only one base station. It could create a problem when you're out of range or something. So with Sigfox, when you send a message, it's going to be picked up by all the base stations which are around. And this is up to us to deduplicate that message and to send the good version to you. So very long range. As I said, one key is actually that it's really, really long range, and I'm meaning it when I'm talking about it. So basically, these radio waves can go really far, and sometimes it's a bit magical for me, to be completely honest. And it's really, really dependent on topography. But in best case scenario, I got yesterday morning a text message from one of my startups telling me that his station was picked up 200 kilometers from there with an antenna. So you can, of course you can't expect that in all the use cases, etc. But we have some really rare use case where these kind of radio waves can go up to this kind of distance. This is ideal case when it's line of sight and it's really like in a rural area, etc. In reality, what we can see more is that in cities, for example, you can have a few kilometers of range, which is fair. So for example, in Paris, you can expect a few kilometers of range. And in the countryside, you can expect tens of kilometers, like 50 or 60 kilometers. As I said, it highly depends on topography because it's radio waves. So it's bouncing on buildings, etc. So it's really depending on topography and your neighborhood. One important thing is to understand that it actually works indoor. Sigfox works really well indoor, and I'm going to showcase that to you with the demo in the end. So yeah, it works indoor, but it's not magic. You can actually guess from your phone, for example, that you get a lower reception when you're inside when you're outside. This is the same for Sigfox. It's radio wave, so it's not magic. So we are applying the same physics rules. What we can do on our side to make it work even better is to be sure that you have full coverage, that your device is working really great, etc. But yeah, you have to understand it works really well indoor, but it's not magical. So we listen. If you look at internet, you will see a really lot of crap said on Sigfox because they don't know what they talk about. But our protocol is bidirectional. So it means that the device can send a message to the cloud, but the cloud can also send a message to the device. So it's really bidirectional. We use uplink and downlink messages. But the particularity of Sigfox is that both of these communication have to be initiated by the device itself. So even if you want to talk to the device, it's the device itself that has to ask for an update instead of pinging him directly. So basically, if you would like to update your device, you would have to wait that your device is, pick up the network before to be able to talk to the device. And it's a bit it can be limitation sometimes, but for most of the use case, it's actually better because we save a lot of energy not to listening to the to the environment so many times. Yeah, so I've said a lot of really good things since the beginning. It actually looks like magic, but it's not. In order to do all these things, we have some limitations. And to be honest, it's kind of great because for what we do with IoT use case, this is actually enough. So you could actually send 12 bytes with the Sigfox network per message. So 12 bytes is, for example, it's 2 GPS coordinates, so latitude plus longitude. So it's a lot of different cases. So you can fit a lot of message in 12 bytes. You can send 7 messages per hour. So it's the same, but in other terms, you can send 140 messages per day. I wanted to put the limit of 7 messages an hour because to explain to people. Normally, you can send one message every 10 minutes with Sigfox. But if you want to send 5 messages in a row in 5 minutes, you can. But you have to shut your device down for 55 minutes. So the granularity of how much you send data is per hour. If you understand quite well, that the technology actually can go way more than 7 messages per hour. This is not technology limited. It's because we have to comply with the local rules of radio, frequency, and so that's why we can only go for 7 messages an hour. The technology itself can go to 100 bits per second. So if if we would be continuously sending message, we can go way more than 12 bytes and way more than 7 messages an hour. So yeah, so this is what I was mentioning. So payload example, GPS coordinate is 6 bytes, temperature can be 2 bytes, a state is only 1, heartbeat or an update request can be 0 because the message itself is the message, so you don't need any more bytes. So that's very important. And one message that we really want to send to developers is that the shorter your message will be, the more battery you will have. So we are challenging application developer and device makers to make their Sigfox message as small as they can, because we don't fill up the message with zeros. So if, for example, your message is 1 byte, of course there is you have your payload and there is something around it to make it understandable by the Sigfox network, but we won't fill it with zeros. It means that when you send it, it's going to take less time, and then you're going to consume less battery. So we challenge every time as we can to the device makers to make it as small as possible. And this is an example of payload that I was explaining a bit before. And this is the attention frame that you can see at the bottom. So about the low-cost parts. So first, why is it low-cost? First, for the subscription fees. As I said, it's a network which costs doesn't so much money to deploy and to maintain. So that's how we can actually make few really low subscription fees. You also have a very short software development cycle. As I said, it takes a couple of lines to send Sigfox. It's very easy. Of course, there is some mastering to do, etc., and it's not as straightforward sometimes as it should. But it's very easy to understand. It's very easy to do. Usually when we do our workshops, in a couple of minutes, people already send their first message and understand how it works, etc. One important part, again, is the hardware components part, because when you do millions of devices, they have to be very cheap. And this is where Sigfox is really good, because we have an open hardware approach where everybody can do a Sigfox chip. We actually provide the Sigfox stack for free. And everybody who do transceivers, SoC, or whatever, they can integrate this stack for free. So, for example, right now we have TI, we have Atmel, we have onsemi, we have a lot of different transceiver maker and SoC maker doing Sigfox. And then you can actually play the competition to get lower price for millions of devices. And this is really important when you want to do millions of devices. You need competition to provide different type of chips. So a big point is security, and I'm going to introduce this slide by saying that security is always an ever-ongoing effort. We will never say that security is checked. That's completely wrong. So that's important to say. But on the other side, Sigfox is actually pretty secure for a lot of stuff. By default, the payload is not encrypted on the radio part, so we don't encrypt data when it's going on the fly. But it's up to the customer to do it, depending on how critical is the use case. So we actually, if the use case is very deep security, we really say to them to secure it and to encrypt it, depending on what they want to do. Of course, message can be encrypted or scrambled. So if you don't need a really, really high level of security, you can scramble your message, because if somebody can look at it and don't understand what it means, that's already something. So a good part about Sigfox, of course, is there is no keys exchange on the network. There is nothing, no handshake, etc. So you can't listen to keys on the network. This is very important to understand. And we also are very strong against message repetition, man-in-the-middle attack, all of these kind of attacks are very, very well covered with Sigfox. So radio properties. This is really important. I'm saying that at every slide, but because everything is important. Yeah, this is something which we are really happy about. Is that we are really, really high tolerance to interference. And what it means that you can't really jam a Sigfox network with normal means. So, for example, of course, if you wanted to jam Sigfox, you could with millions of euros of equipment. But for today, for example, you could buy a 3G jammer on the market. You can go on Alibaba, buy a 3G jammer, and jam a whole network for a whole building or something like that. With Sigfox, it's not possible, not with actually the means of everybody. And this is actually creating a lot of use case for us because we are very secure, very tolerant to interference. And again, interception of the message is hard actually with UNB because we are sending message at different frequency, and we are using a technology called the ultra narrowband. So this is actually made for it, and this is why we are very, very hard to intercept. So this is one use case in security. So I was mentioning what we are really, really hard to jam. So this is a very, really famous company in security. They are doing housing security. Basically, they had alarms in their houses working on 3G and 4G. And what they realized is that people were going into the houses with 3G and 4G jammers and jamming completely the network. So their alarm systems were sometimes not going through, and it was a problem because then they were robbed. What they implemented with Sigfox is that every time they actually can see or they can understand there is a jammer next to them, so where they can see there is no 3G network anymore, then they are sending a Sigfox message to send an alert. And the Sigfox message actually will go through the jammer, not a problem. So the Sigfox here is used as a backup solution if they think there is a jammer in the house. An interesting fact with this case is that with the open world hardware approach here, they were able to use existing hardware and they made it Sigfox compatible. So because they had chips which are compatible with our frequency, we had the antennas, etc. So they just upgraded over the air all the hardware, and they made it Sigfox compatible thanks to this open hardware approach that we have. So here I'm not going to stay that long because I'm not really, really good in radio, but the first one you can see is UNB, is what we use. And as you can see that the signal of UNB goes through the interferer, and that's still why you can see the message, even with interferers. When you can see that the spectrum technology, then you actually will miss a part of the message, and then you will actually have more problems to actually solve it. So the ultra narrowband part, which is what we are basing our technology on. I'm not going to spend a long time here, but I wanted to showcase to you what is radio and what it looks like. So currently we are listening to a 200 kilohertz part of the spectrum. We are not listening to the whole band that we should be with, because it's for us, for now, it's useless. We already have way more capacity than we actually can, but we are producing, so it's actually way more than enough. And every Sigfox message is 100 hertz wide. So what does it mean? It means that. So this is what the spectrum looks like on our own base stations. So you can see from the left, numbers 868.34 to the numbers on the right, 868.26. This is this 200 kilohertz that we are listening to. And this is how a shared spectrum looks like. You can see it's not perfect. You can see other people are using it. The spectrum is a bit dirty. And so our UNB technology can allow us to actually recognize this message in this mess, even when it's really, really heavily used by others. So what a Sigfox message looks like, and you can see on this slide the 3 little dots in the back. You can see 3 repetition, because basically every Sigfox message, when we send a message, it's repeated 3 times. You can't see it yourself, but this is how the protocol works. So yeah, you can see the 3 repetition here. So make it a bit bigger for you. These are the 3 lines that you can see with the round thing around. And this is what a Sigfox message looks like. So about the frequencies. So we are using, and that's why we could actually build our own network, we are using free and unlicensed frequency. The good thing about that is that they are free. The bad thing about that is that they are shared. You have to share with everybody using it. So it might be radio amateurs, might be other competitive technology, etc. So you have to be able to pick your message amongst this mass. This is very important to do. And of course, when you are using this free band, you have to respect some rules because you don't want to overflow a free band. And so you have to be compliant with the ETSI rule in Europe. So it's linked to the 868 megahertz frequency. And in the USA, it's a different frequency. So it's 902. And this is why I said earlier that the network works exactly the same everywhere, but your device, if it's in the US or if it's in Europe, it has to behave a little bit differently. It has to know that it's on a different frequency. So it can be exactly the same hardware, but it has to send on a different frequency, which is completely doable. And we already have some devices which can do both. So hardware solutions. Again, we are using this open hardware approach. We are working with established partners like Atmel, Texas Instruments, Scilabs, Axem, Team, Telecom Design, and a lot of them. So they do different things. For example, Atmel do a system on chip, which is compatible with Sigfox. TI does a transceiver compatible with Sigfox. Telecom Design does really famous modules for Sigfox. Team do also do modules. Telit also. Axem does a SOC system on chip as well. So as you can see, there's a lot of people doing different stuff, and it's really, really good for the device makers because they can choose between different kind of technology they want to use. It might be a module because it's really, really fast to start. It can be an SoC because it's way, way cheaper. So it's very depending on how much device you want to produce and how much you want to spend on it. I mean, it's very depending on you. And the good thing about having multiple providers is that you can do whatever you want. You can choose within them. Which can be interesting to you is how to prototype. And the good news here is that we have a lot of prototyping boards. We have Arduino boards, we have Raspberry Shield, we have Atmel kits. I mean, we have a lot of different ways to start with Sigfox. And they are very easy to start with, but please don't go in production with that. Don't go in production with an Arduino board. Just don't. It's really good to prototype, but it's not made for it. It consumes way too much power, etc. And then you lose the whole value of having Sigfox. So please, if you want to do your production, don't go with Arduino. One important part with Sigfox is the antenna because it's radio, so it's very the reason for it. So it varies really a lot of different forms with actually antenna. So you can remember 15 years ago that your phones had a really, really like thick antennas on the top, and then it moved to antenna in the phone itself, etc. Then it's exactly the same for connected objects. So you can see objects which needs to power a lot, which need to be really deep in the ground under the ground, etc. This one need really high antenna, like really big antennas. But for a really small device that actually are outside, etc., or even indoor, for example, you can have watches. You can have antennas which fits in watches, for example. So it's really up to you, and it depends what you want to do. If you don't know how to do an antenna, please ask somebody. Don't screw a project because you said, oh, antenna is easy and I'm going to do it myself. No, never works, always fails. So please, if you don't know, go ask somebody. And antenna is always a balance between the design and the performance. As I said, if you want the best performance, your antenna is going to look bad. It's going to be a big antenna, and because you are very deep in the ground. If you want an antenna which fits in a watch, of course you need to be smaller, and then you have a little bit less performance. So it's really it's a choice between both. Coverage, because everything is really good, but where does it work? So our coverage is actually live. It's online. It's officially, and we are maintaining it. So you can see that we are fully deployed in a lot of countries like Spain, Portugal, France, Belgium, Netherlands. So Ireland is going really fast. Italy is going very fast as well. Czech Republic is going very fast as well. UK, we are deploying it right now. Germany, we are deploying it right now. We're going to announce stuff in the coming months. Denmark is deploying right now. We are also deploying it in the US, which is a very small country, so it's not going to take a while. No, it's going to take a bit more time to cover US, but it's our plan to do so, so we'll do. This week, we announced as well a really small country called Australia, and another one called New Zealand. So basically, these one are going to be covered. They are starting this year, and we are going to finish next year. We also announced Oman, which is a country in the Middle East. So, and the good thing with deployment is that we learn during the process how to deploy faster and faster. So, for example, in Portugal, we are really proud of saying that they deployed the whole country in 2 months. So it's very, very impressive to see. And in Ireland, the coverage that you can see was made in 4 months or something like that. So if you know how to deploy like a network, going with Sigfox is going to go very fast. So yeah, this week's update was Australia and New Zealand. So I really hope I can do events there. And to finish, some of the use case we have right now in production. So just to let you know, one important part about the Sigfox use case is that it's IoT right now. When you look at the press, etc., it's all about the sexy stuff, the watches, the gadgets, etc. But actually, the biggest part of the money which will be made in the future in IoT is the stuff which is completely invisible to you. It's the stuff which is not sexy at all, but which makes a lot of value from what it makes. So I couldn't find less sexy than water metering. It's basically a water meter that you put on your water consumption, and it will tell to your provider how much you consume per day. As stupid as that. But then you remove the need to have somebody who go to your place to do it by hand and to actually annoy you every time, etc. So a really small device, dumb, but which creates a lot of value. We have a lot of use case in the silver economy as well. So silver economy is economy with elderly people. Here you can see a box with it's a completely autonomous box, sorry. So it's completely autonomous box, and we will actually help people going in. The last one is smart parking, of course. So this is really, really important. A lot of smart parking use case right now, and so yeah. So this one actually has a lot of success every time we showcase it. It's connected beer. And what does it do is that it's predictive maintenance. Basically, it will tell you if the beer is always cold, and more importantly, it will analyze how it behaves. And if there is any sign of the beer tap going down, it's going to send a message to the beer tap provider and say, hey, I need a change of some piece in me, please come and change that. And then, the beer tap maker, he doesn't sell you a beer tap anymore. He sells you a service of having a beer tap which is always running. You're never going to lose a night anymore. And this is important to understand the kind of services that you want to build on top of this kind of dumb message in your devices. We also have connected pallets. As I said, asset management is a really, really big part of Sigfox, tracking where your goods are, etc. We have connected beehives. So a lot of use case around bees. Don't ask me why. Actually, there is a huge market for it. It's basically a scale which weights how heavy it is, etc., and send this message through the Sigfox network. We're also working a lot in agriculture. So this is WinAds, a startup doing agriculture sensor. Captures, this one is French as well, very famous because they do outdoor GPS trackers. So for outdoor extreme activities like ultra trails and outdoor skiing, freestyle skiing, etc., where sometimes you need a device to work for a few days and still working with GPS. So that's very important. So it basically tells your family where you are every time, and it makes you safe when you go alone in trailing, etc. So this one is as well with the French post office. So it's basically a button in your mailbox where you push when you want to send something. So you go to your own mailbox. If you want to send a package, you push that button, and the post guy will pick the box up in your own mailbox and ship it for you. Connected trash, as I said, very important because you can optimize a lot of stuff in cities with that. And yeah, a last one. It's about the Sigfox Foundation and the use case we make about it. So when we launched the foundation a couple of months ago, the idea behind it was to showcase to people that IoT was not only about gadgets, it can actually save lives. And this is what we did with the foundation. So they actually put 2 base stations on the Belgium station in Antarctica. So, where you have researchers. So 2 base stations on Antarctica, and they gave 40 GPS trackers to all researchers on the base. And now they actually love it, because now every time they go outside of the station, they know where everybody is. If they have a problem, they just have to press a button and somebody is going to pick them up, etc. And it's provide them a security that they couldn't get before. And we'll showcase the results of this, I think, later this month. But the feedback from the researchers is amazing. And it actually allowed them to do way more than they could before. And for us, it was just GPS trackers, which are 50 euros each. So it's not a big investment. But for them, it's a huge advancement. So IoT is way more than just gadgets. And so this was the first mission with the foundation. The second one will be about saving animals in Africa. So we probably will work with rhinos in Africa. And one of our next will be saving fishermen with connected life jackets. So I think that's going to be it, because I'm not going to be in more details. The cloud part will be completely useless for you, as you haven't started. What I can do is showcase you a demo. So Fernando, are you still here? Fernando? Yeah. Okay, so I'm going to showcase Arduino now. Okay. So I wanted to showcase to you how easy it is to do Sigfox. So you can see my Arduino IDE here. And what I'm going to do, so you can't see it, but I have an Arduino board with me. So maybe I can actually. No, I can't. So anyway, so this is my Arduino code. I'm gonna upload it to my Arduino board with Sigfox on it. So it's uploading. Yep. Oh. Sorry, I need to move. Oh, okay. I lost something. So I need to open the Sigfox backend. Can you still see my desktop?
Correct. Right now we see the browser.
Okay, perfect. So the device I'm actually using is this one. It's the R1D7FE. And so you can see that I just uploaded the sketch, and it's actually already communicated on it. So just to show you something, so I'm at home, so I'm indoor in Paris, and you can see that this is all the base station which picked up my message. So it's around 20 of them or something like that. So if I want to just to showcase something to you, so where are the base station which picked up my message? I can do it with a really neat tool we did. So these are all the base stations which actually picked me up from my place in Paris. So you can see that it goes really, really far, actually. And just to show you that I'm not lying, I'm going to actually change some stuff in the code of Arduino, and just to show you that I'm not actually a liar and I'm doing that live. So I just changed the message that you sent. I uploaded the new code on my Arduino board. So now it should send a new message. I'm going to wait. Up. Yeah, and here it is. So now I have 1, 2, 3, 4 cafe, which is the data that I sent and modified. And as you can see, it took less than 1 second to actually showcase here. And I was picked by, let's try again, how many base stations picked my message? This time, 16. So yeah, I'll bet you Funny thing with radio wave is that you can see that there is a base stations near Cergy, Pontoise, which picked my message when I live in the Kremlin-Bicêtre, south of Paris. So you can see that radio waves sometimes are kind of funky. So yeah, I mean, from my side, I think that would be it. Maybe we can go to questions. Now you see that it works, and yeah. But by the way, I'm indoor. So for people who don't believe that Sigfox works indoor, I have 16 base stations which prove you the opposite. So yeah. So maybe we can go on the YouTube page to see the comments.
Definitely. Okay, so let's start off with the first question. Is what are the advantages and drawbacks of Sigfox technology compared to LoRa?
So if I wanted to be nasty, I would say that we have a network. Still they don't. No, I mean, I really have to understand that it's very, very different. LoRa is technology made for private networks, and it's really good if you want to deploy your own network with your own antennas, etc. It's made for that. When Sigfox is really made for public use case, when you want to use, when you don't want to carry the infrastructure by yourself, we provide a service, not a technology. We provide the service of, you send a message on our network, and we are going to provide it back to you on your web server. On LoRa, you have to handle everything by yourself and build everything by yourself and build your own private network. So it's a very, very different thing. And we sell a service, they sell a technology. So it's very different. If you want to compare Sigfox against LoRa, on the technology side, you can see that disk91.com did a very, very good analysis on how easy it is to do devices, etc. with them. The guy is using Sigfox and LoRa since a long time. So if you want just to look about the technology side, please go on disk91.com blog, where he has a very good analysis about it.
Okay. Our second question is, what about security? If messages from the device are being broadcast, then everybody can spy on devices?
Sorry?
His question is, what about security? If the messages from the devices are being broadcast, then everybody can spy on devices, can't they?
No, actually, so it's various two answers to that. First, you have to understand that indeed the payload of the messages are not encrypted by default. If the use case has to be secure, we actually say to the people and you encrypt it. So today, most of the use cases which require security are all encrypted on Sigfox. It's very easy to do, etc. So most of the use cases are encrypted. Now, of course, it's radio. Like every other technology, you could listen to the air. But then you have to understand a lot of stuff that you can't understand, right? You have to understand who is talking, which device is talking, what is it saying, because usually messages are scrambled. So there is a lot of different stuff that you have to understand to actually understand what the message means. So even if you are able to listen the 0 and the 1s on the air, which you could do, then it's another matter to actually understand what they mean to actually use it. Then there is another thing is that, as I said, we are really, really quite protected against man-in-the-middle attacks. So if you wanted to be able to repeat your message, so listen to a message, and you don't even understand what it means, but you listen to it and you want to retrieve it again, then you can't do that, because our server will actually look at the message and say it's completely wrong, because we have some hashmark security issues, some hashmark security systems which will tell you that's not a good message. So there is a lot of answer to that. I can't answer about security in 1 minute. Security is way too wide, and here we are only talking about the radio protocol security, when actually security is from the device itself to the overall cloud platform, etc. So there is no easy answer to that, and I'm not going to be able to answer that in 2 minutes. But if you want to talk about that, please come to me. I'm completely open on Twitter, etc. Please come to me.
Okay. Our next question is, it would be awesome to get some coverage in Berlin so people can start trying it out.
Berlin. So I can't Yeah, I can't talk so much, but we have some coverage in Munich since a long time, actually. Germany is one target for this year. We announced that we will got coverage in Berlin very, very soon. We did a PR, I think, if it was in February about Germany. We have some we have some people already there. So you can expect having coverage in Berlin quite soon. I don't even, I can't answer more than that, but if you want to know when exactly, please come to me. I have some news for you.
Okay. Our next question is, where can we test the connected beer server?
You had to come to MWC for that. I'm sorry. So we had it on the booth at MWC, and I don't know why, but it was the demo who had the most success ever.
Sounds reasonably why.
Yeah.
Our next question is, can I use Sigfox for OTA, over-the-air updates, for firmware update?
Yeah, of course you can if your firmware is less than 8 bytes. So no, you can't. The obvious answer is no, you can't update your message with Sigfox. It's not made for that. What usually my customers do is that they implement different modes in the device itself, and they use a downlink to change this mode. So for example, if you realize that you're sending way too much data, or that you need to send different data, etc., they use the downlink mode to change the mode of the device. This is how it's used, basically. Some others are using, for example, USB cables to do updates, or Bluetooth. They light on just once to do an update, and they shut it off after that. So yeah, there is different ways to do that. It's not perfect, but for now, what we have works quite well.
Okay. Next question is, who establishes the transmission limit, the Sigfox transceiver or the APP module?
So the APP modules. So basically, who establishes the connection is the device itself. The device itself is broadcasting a message to everybody, and the antenna are listening to it. So that's important to understand. This is not the antenna will say to the device, "Hey, put you on this channel," etc. No, the device wakes up, sends his message, and go back to sleep. So the device only does what it needs to do, and then we, with our network, ensure that you get your message gets acquired. I don't know if I answered the question, but I hope I did.
Okay. And currently, our last question is the Sigfox communication 100% safe? Are there ACKs after each transmitted frame, or how does it work?
Oh, so okay. So you mean if every message is acknowledged? So no, but you can do it by yourself. So for example, we have a use case where the device have to know if the message was received or not. And so what they do is that they send a message with a downlink request. And so basically, they use a downlink as an acknowledgement of the network. So because if the network picked up the message and sent a response, it means that it was picked up. So this is a way to do it. But no, every Sigfox message is not acknowledged. There is simple reason for that. First, because we don't want it. It could be an infinite loop. The server could send an acknowledgement, the device could send an ACK back. It would be a bit of a mess. And actually, with Sigfox, we have SLAs, so quality service. Use case. So we ensure you that your messages are gonna be picked up by, I don't know, 99% of the time or something like that. So you're gonna trust the network to be picked, and this is important. So there is one last trick that people use as well, is that each message has a special number. So if you actually realize that you missed one frame, then you will see it on your backend, and you will receive an alert and say, "Hey, one message was not received," and maybe in this way you could ask the device to send it back. So this is This is what some of the GPS trackers are doing.
Okay, and we have one more question. Do device providers have to implement specific Sigfox capability on their connected objects, and how to recognize them?
So yes, if they want to do a device with Sigfox, they have to take care about it. There is really different methods to do it. Either you can take a module which are very easy to implement and done by Telecom Design or Telit or stuff like that. You talk with it with 80 commands, so it's very easy to do. It's really a couple of lines of code, but then it's a bit more expensive. So that's the thing. And after that, if you want to go cheaper and smaller, you can go to system on chips or transceiver, but then you have to integrate it yourself, and it's a bit more complex. But we have already some French startup doing Sigfox enabled devices. You can look at Captures, CAPTURS, captures.com. You can look at CoAssist, which is now crowdfunding. It's the first watch connected with Sigfox and GPS for elderly people to be able to track them when if they are lost or something. So we already have some really good consumer device using Sigfox, and which implemented it quite not easily, but they implemented it in a short time frame.
Okay. So our next question is, what about price? How much does it cost a device subscription?
So first, I didn't say it, but consumers won't be allowed and won't be able to buy Sigfox. So it's really the device manufacturer will provide the connection with the device. So it's not a subscription model where you as a consumer, you will be able to buy it. So it comes with a device. And for now, what we say is that it's the most expensive part of the price grid is if you take, for example, a couple of devices and you want them to send a lot of messages. So the maximum messages per day, it's going to cost you €1 per month per device. But then there is, at the extreme opposites of the price grid, if you want to send 1 or 2 messages per day, and you want to buy millions of devices to Sigfox, it's going to cost you less than €1 per year per device. So of course there is some insight, some other thoughts onto this price grid. And I'm on purpose not giving it completely exactly because it's under NDA. But yeah, this is a price that you can expect from Sigfox. If you want to do millions of devices, few messages, less than €1 per year per device.
Okay. And currently our last question is, do you feel confident about Sigfox's future? It's Sigfox against the rest of the LoRa Alliance, and why?
So, I was working for 5 years at Intel before. I had an amazing job, and I still went to Sigfox. So that's, I think, the best, that's the best piece of trust I can actually put that, is that I trusted so much that I left my dream job to go to Sigfox to do an even better one. So yes, I believe Sigfox is going really well. The momentum we're seeing is amazing. We are deploying networks faster and faster. So I handle all the startups doing Sigfox, and I can tell you we have a lot of requests to do it. And now it goes faster also to develop product. It goes cheaper with Atmel system on chip. It goes really, really well. And again, the LoRa Alliance, it's not a big problem. They deploy private networks, and we deploy public ones. That's not a big problem. From what I understand, they still are rolling. That's not a big problem for us.
All right, like a boss. Let me just check to make sure there's any other questions.
Yeah.
Okay, sounds good.
Sounds good. And by the way, if you have any questions, please, I'm available on Twitter. So where is my Twitter account? It's here. So it's _ANTH0_. So this is me with my crappy picture, and this is my Twitter handle. So if you need anything, let me know. I'm going to answer to that. My email address is anthony.charbonnier@sigfox.com. If you need anything, let me know as well. We'll be really glad to help you with everything. We are working a lot with makers as well, with developers doing a lot of Arduino showcase, etc. I was again yesterday in Portugal to do some workshop with Arduino to engineers, etc. So if you want to know more about how to do cool stuff with Sigfox, please let me know.
All right. So I just want to say again, thank you, Anthony. Thank you to the entire Sigfox basically program for letting us do this webinar. Everyone else, if you have any other questions or if you want to find out more information, as I mentioned, you can always just register on our community. So that's community.bemyapp.com. And with that, I say if it's evening for you, have a good evening and have a good day, everybody. So cheers.
And have a good day, everybody, and enjoy your day.
So yeah, back.
Bye.